Hi everyone, this is the last video for chapter 14, and in this video we're going to talk about organic reactions, about how the bonds break and how what types of organic reactions. Okay, this is the learning outcomes. Okay, we will start to learn about homolytic heterolytic fission, about nucleophile, electrophile, and some of organic reactions such as addition, substitution, elimination, hydrolysis, condensation, oxidation, reduction. Okay, we will start from homolytic fission and heterolytic fission. Okay, homolytic fission is where the bond dissociate, yeah, and this process occur when each atom keeps one of the shared electrons. And the result for homolytic fission is a neutral species with unpaired electron that called as free radicals. Okay, you can see that the homolytic fission of chlorine here can be shown by drawing a fish hook arrow. Okay, usually we draw arrow like this, right? This is a complete arrow, complete head. But since the bonding electron here will be shared to its two atoms equally, you should draw like this. Wait a minute. Okay, this is called as fish hook arrow. Okay, that means only one electron that goes to one atom. Okay, look here. This is we call as start. Okay, and then this is final. Okay, this arrow very important because it shows about how electrons move from the start point to the final point. Okay, please remember that the start point is the location, the initial location of the electron. Okay, in homolytic fission, the electrons that we want to move located in here. Yeah, the shared pair of electrons. This is a single covalent bond made from one electron from the Cl and one another electron from the other Cl. So once again, let's make the fish hook arrow. Look here. This means one electron from this. Oh, something wrong with my pen. Okay, look here. Okay, look here, yeah. This is one to the right Cl. One more to the left Cl. Okay. So once again, actually this is a single covalent bond like this. So one electron goes to each Cl atom. Okay. So the result will be Cl with lone electron like this. And then the right side also Cl with one electron. This species is called as free radical. This is a very reactive species since you know that electrons want to make pairing condition. Yeah, so this free radical is very reactive. It will try to get another electron. Okay, so once again, through homolytic fission, the two free radical will be formed. Okay, understand? These homolytic fissions will not occur if there is no trigger. The trigger for these reactions is UV light. Okay, so once again, homolytic fission only occur if the UV light present. Yeah, it is a source of energy for the homolytic fissions to occur. After we learn about homolytic fission, let's see about the second fission. It is called heterolytic fission. In this fission, the chemical bond dissociate by a process where both of the shared electrons go to one atom. Okay, resulting in a negative and positive ion. Okay, So you will see that we will use a curly arrow. This is called as curly arrow. And you can see that it has a perfect hat. Yeah, this is hat. This shows that 2 electrons from the covalent bond goes to one atom only. So if you see here that if we have AB, you should draw the curly arrow from the bond the covalent bond from here to here. Okay, this is too far. Yeah, this is too far. It should at B. Okay. So please don't draw the curly arrow, for example, from this to this. Okay, this is wrong. Why? Because once again, the curly arrow shows about the electron's movement from initial to final. Okay, if you draw like this, is it electron? No, this is atom, the symbol of an atom, right? Okay, and then where it goes? Yeah, so this is wrong. Don't draw like this. Okay, another students make the curly arrow like this. Okay, this is too far. Okay, the initial is already correct from the covalent bond, but this is too far. Where? Yeah, this is not correct, but instead of this, to B. Okay, this is how you draw the curly arrow for heterolytic fission. Okay, you can imagine that the shared electrons goes to one atom only. So this makes the another atom, which is A here, lost one electrons, and so it will change to A plus, the cation, while B received 2 electrons. So that means it will have negatively charged. Yeah, it have negative charge. Yeah, since for example HCl. Okay, you know that before like this, right? And then 2 electrons here goes to Cl here. So this will change to H plus and Cl minus. Why Cl minus? Since now it has 8 electrons. Yeah, 8 electrons. Before Cl has 7 electrons, but now it has 8 electrons. So this is Cl minus. Can you understand? Okay. So what the differences between homolytic and heterolytic? Homolytic fission, half arrow, fishhook arrow, while hetero, complete arrow. The product of homolytic fission is free radical. Free radical is a neutral species, yeah, a neutral species with single electron. While in heterolytic fission, it forms cation and anion, positive and negatively charged ion. Okay, like this. So understand, yeah? Oh yeah, in homolytic fission, UV light should be present, but for heterolytic fission, no need. Okay. In heterolytic fission, the more electronegative atom takes both the electrons in the covalent bond. So that's why I draw the curly arrow from the covalent bond to Cl, not to hydrogen. Okay, since electronegativity of Cl is higher comparing the H. So this will give H plus and Cl minus as the product. Okay, so later on you will see that in halogenoalkene, yeah, we already see about 13 functional groups, yeah, in the first video. So one of them is halogenoalkene. So please remember, in halogenoalkene, the bonds will break through heterolytic fission from the covalent bond to the Br, not to the CH3. And this will gives you the product CH3 plus with Br minus. This is strange because usually carbon will not have charge, right? Carbon is a non-metal, so usually it will have no charge. But in case of halogenoalkene, you can see that carbon will have positive charge. This species is special and it is called carbocation. Once again, carbocation, that means carbon that have positive charge. Yeah, this is the result of heterolytic fission, yeah, between C and halogen atom. Yeah, the covalent bond electrons will be goes to electronegative atom, which is Br. Okay, it's practice time. Write an equation to show the homolytic fission of the Cl-Cl bond in chlorine molecule. Okay, can you draw it? Okay, let's compare with me. Okay, from the line, this is the covalent bond to the Cl atom. Yeah, 2 Cl with 1 dot. Yeah, this is free radical. Okay, are you correct? Okay, don't forget to write the UV sign here. Okay, next. For heterolytic fission in chloromethane. Okay. You can see that chloromethane is CH3Cl. In this case, Cl has a partial negative charge since it is a higher electronegativity. Yeah. So the curly arrow will form the covalent bond to Cl. Okay. To produce carbocation, C positive with Cl minus.